Hi, I just wanted to make a quick video to help go over the topic for today. We are making decisions about the domain of an equation based on the way that it's structured. So there's three easy things that you're looking for. Are there any restrictions for my equation? And if there are, what do I have to write in that situation? So most situations that we'll deal with in this course, we won't have any restrictions for the domain. So this is a simple example of a linear equation, and this is an example of a cubic equation. You'll find this to happen on a lot of things. And what you're going to ask yourself initially is, are there any restrictions to what I can plug in for x? All right, so in both of these cases, if I look at x and all the different parts, I'm allowed to plug in negatives, I'm allowed to plug in decimals, I'm allowed to plug in fractions, I'm even allowed to plug in irrational numbers in both of these cases, okay? So even though some of those would be ugly to work with, I'm allowed to plug in values for them, because if I do, I will get an output as a result. In situations like that where you have no restrictions for the domain, you're going to write that the domain is all real numbers, okay? And you've seen sometimes you can write it with an R that looks like that, and then sometimes a teacher will ask you to write it like this as well. Okay, any of those formats are fine for me at this point. Okay, so all real numbers for situations like that. There's also something called interval notation, but we're not going to go over that at this point. Now second, there are some functions that are set up with fractions, and we know we have to be careful with fractions as we're working through many types of problems throughout the year. Okay, one of the issues we have with fractions is that we are not allowed to divide something into 0 parts. So we are not allowed to have a 0 as the final expression on the denominator there, okay? So there are actually a lot of numbers that we can plug in here for x, and this will be okay. We can, again, plug in decimals, we can plug in fractions, we can plug in irrational numbers there. They won't be easy to work with, but we are allowed to plug something in there and we will get an output out that relates to it. But there is one number that we could plug in here and it doesn't make sense and we will not get an output. And that number is whatever makes the denominator 0, okay? And in this case, it's just something you can guess and check. It's obviously going to be -4. But for something that's more complicated down here, what you can check is off on the side, you can do a little scrap work and say, what would make my denominator equal to 0? Okay? Just put yourself a little question mark there. And then obviously you just do a little bit of algebra or arithmetic to figure out what that value would be. So in this case, it's very simple. It's just x equals -4. But sometimes it'll be fractions or more complicated answers. Once in a while, if this is a more complicated expression, you might get 2 answers or more. But most of the time, it'll just be a simple answer. Okay, so x is not allowed to equal -4 for this equation itself. Okay, so this was just scrap work. The value that makes the denominator 0 is -4. So x is not allowed to equal -4. So when you write the domain for this, you can simply, at this point, just write x is all reals with your double R there. Sorry, that's bad drawing. But you would just say a not equal symbol and -4 afterwards. Okay, so something along those lines. And again, this should be a symbol that looks like that. Sorry for the bad handwriting. And finally, the third type, the main of the three that we're looking for that's most troubling to students is this type. So we've got square roots, and it's hard to remember what is not allowed underneath a square root. What we think about is the square root is the opposite of squaring something. All right, so if you square any number, 2, 4, 6, or even the negatives, -2, -4, -6, the result is always going to be positive. Right? The only time you don't get a positive is when you have the square root of 0, which is 0. Okay, so the square root is going backwards from that. So you cannot take the square root of a negative number. All right? If you try to plug in the square root of -5 into your calculator, you're going to get an error message because it doesn't work. Okay, so we have to figure out again what values will make this 0. and then what values will make it negative, and that's going to help us with our situation. Okay, so 0 is kind of your cutoff point, so over on the side I'm going to think x minus 3 is equal to 0. The value that makes it underneath there 0 would be positive 3. Okay, and then from there, what you want to think of is, am I allowed to plug in numbers bigger than 3 or smaller than 3? Or if you're thinking about the number line, am I allowed to plug in numbers to the right of 3 on the number line or to the left of 3 on the number line? So you just can guess and check a few here. So if I plug in 5, 5 minus 3 is 2. That's a positive number. That's fine. Same thing with 6 or 7 or 8. Those are all good. All right. However, if I plug in a number smaller than 3, 2, 2 minus 3 is negative 1. 1 minus 3 is negative 2. 0 minus 3 is negative 3. Any of those numbers to the left of 3 on the number line would give me a negative inside here, and that's what's not allowed. You cannot take the square root of a negative number. Okay, so with that being said, now we have a better understanding of the domain. This time, since there's multiple answers that are restricted in this case, we're going to use an inequality symbol, just like you used on many of the graphing problems. So I'm going to say x with this funny looking e, and then the funny looking r, and in this case that's going to be greater than or equal to 3. Okay, so the number we used over here, and we said we were allowed to plug in numbers bigger than that, so the symbol that goes for bigger is greater. So x is all real numbers greater than or equal to 3. If you don't like this notation, again, you could always write it like this: all real numbers greater than or equal to 3. That's also fine for me. Okay, so hopefully this video was helpful. The activity you're going to do today walks you along a very similar process, so hopefully between the two things you are understanding what's going on here. Thanks a lot for watching.